Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
I am your host, JEFF, also known as A Cosmic Bard over on X, and this is the Lost Wanderer podcast for June 15th, 2025. Happy Sunday evening, happy Father's Day, and welcome aboard the ACS Serenade. Our leading story tonight, we're going to talk a little bit of NASA and President Trump here. For Jared Isaacman's name is already etched into the emerging history of private spaceflight. Commander of Inspiration 4, the first all-civilian orbital mission, and the force behind Polaris Dawn. Isaacman is honestly part of a rare breed, an entrepreneur who puts his own boots in the capsule. But this week, the story took a bit of a sharp detour. One that doesn't end on a launch pad, but rather in a quiet, unresolved moment behind the scenes of American space leadership. In two separate interviews, one with written in the Ars Technica and the other one in Space.com, Isaacman confirmed that there had been some whispers in the aerospace community for over a year, and he had been basically undergoing vetting to become NASA administrator under a potential second Trump admin. That said, it wasn't speculation. It was actually happening. He was vetted extensively, passed every check, and coordinated closely with NASA leadership to ensure transparency. That process took months. He made his positions clear. He didn't seek the role, but once approached, he engaged in good faith. Then, without warning, the momentum stopped. The nomination never materialized. No statement was made. His name erased from any further shortlist discussions. Instead, it seems Trump's campaign began favoring retired Army Colonel Douglas Macgregor, a man known for his media appearances more than, any aerospace expertise. That said, the contrast couldn't be sharper. Isaacman is an active participant in spaceflight, actually having been out on a spacewalk. Macgregor has no known background in space or science. Yikes. Now, Isaacman didn't offer much speculation in his comments, but he acknowledged that many already suspected. In his words, "I think I was a good visible target," meaning his close association with SpaceX and probably even more so Elon Musk. And of course, the ambitions of Polaris made him a lightning rod in any political storm. And it's a bit of a strange place for someone like Isaacman to find himself. After all, this is the person who not only funds missions, he flies them. He trains like a NASA astronaut. The Polaris program is working toward milestones like commercial spacewalks, deep space orbits, and next-gen suit testing. These aren't theoretical missions. They're active training operations involving SpaceX, former NASA astronauts, and live flight simulations. In short, Isaacman has been doing the kind of work NASA sort of quasi still does, maybe. And while the agency has embraced partnership with private companies, it is still struggling to define the balance between public leadership and private innovation. Now, NASA Administrator Bill Nelson, a former senator and space shuttle payload specialist, has served the role since 2021, and I will still go on record as being that is the only decent Biden pick. His tenure has been marked by, some questionable Artemis planning. He did have support for commercial partnerships and a relatively strong international outreach. But Nelson is in his 80s, and regardless of political outcomes, a leadership transition has to be inevitable. Now, this could have been a very pivotal moment, a chance to bring old and new, aligning someone with real commercial flight experience into the government's top space position. Instead, we saw a bit of a retreat from that idea. And what's worse, no real formal explanation. Just no policy difference was even cited. It was just a vanishing act. Now, Isaacman is going to continue moving forward. Polaris Dawn remains on the books with ambitious goals, including a high Earth orbit profile, ionospheric experiments, and the first use of SpaceX's EVA suit in the vacuum of space. He does remain committed, hopeful, and diplomatic, at least. But it's hard not to see the missed opportunity here, not just for Isaacman, but for NASA as an entirety. I'm still shaking my head at it. There are valid questions about how a private sector executive would navigate the complexities of a public agency and the bullshit of government, but Isaacman was clear that he wasn't trying to privatize NASA or hand over launch control. His goal was more of alignment, not upheaval. And at a time when space exploration is accelerating from lunar landers and commercial stations to Mars-bound hardware, let's face it, alignment is exactly what the agency needs. Sadly, it's come down to basically billionaires versus government scientists. It's about a trajectory. And this one for now, I'm sorry, is kind of been left falling short like a Chinese rocket killing cows. Kind of frustrating. Now, while Isaacman's path to leadership was grounded, some in Washington are now pushing to give NASA's biggest programs a bit of a fresh boost, if you will. When it comes to NASA's future beyond Earth orbit, the numbers are starting to look a little grim. You have Gateway, Orion, and the Space Launch System, basically what was the backbone of Artemis. Well, they're still facing funding shortfalls. Delays are stacking up, contractors are uneasy, and the 2026 moon landings look more like a hopeful footnote than a solid date. Enter one Senator Ted Cruz. In a move that's as political as it is planetary, let's just call it what it is, Cruz is spearheading a new proposal that would inject $10 billion into NASA's Moon and Mars programs. The legislation, titled the Moon to Mars Act of 2024, aims to stabilize funding for Gateway and Orion, protect the Artemis mission schedule, and ensure the United States remains at the forefront of deep space exploration. It is a bold proposal, and one that comes with, well, a share of politics and promises. The bill outlines a multi-year funding strategy, something NASA desperately needs for long-term projects like the Gateway Lunar Outpost and crewed Orion missions. Without it, key hardware development could be slowed, delayed, or even scrapped entirely. Cruz's proposal specifically calls for mandatory minimum funding for the SLS rocket, continued support for Gateway construction, a formal commitment to the Artemis schedule, and even language supporting commercial partnerships like SpaceX's Starship HLS lander. It is a bit of a sweeping gesture, and one that would have been unthinkable a few years ago from a Congress often hesitant to back NASA's more expensive ventures. But there is a little bit of a twist in this. This bill isn't just about science. It's about national pride, economic interest, and global positioning. China's aggressive lunar goals, coupled with its new Chang'e missions and expanding station program, have kind of reignited Cold War-style urgency in Washington. Cruz, let's face it, for all his partisanship, is actually making a fairly reasonable bipartisan appeal here. He's already drawing support from fellow senators on both sides of the aisle who see the moon not just as a destination, but as real estate for influence, scientific, industrial, and of course, their magical word, political. Now, of course, $10 billion doesn't guarantee success. NASA still faces internal hurdles, contractor delays, and technological challenges. But this kind of legislative push could buy it a little bit more time and maybe even more buy-in at a moment when enthusiasm for space is once again rising on Capitol Hill. Now, whether Cruz's bill clears both chambers remain to be seen, but one thing's certain, Artemis needs more than vision. It needs a good bit of cash, really good coordination, and the congressional muscle to back it up. And this week, maybe, just maybe, it's felt in the first little baby footsteps of finding some. But as we have lawmakers debating how to fund the future, elsewhere we have space leaders that are already gathering to imagine what comes after the moon and far beyond. Next week, if Los Angeles is still standing, some of the brightest minds in space science, engineering, and policy will gather not to argue about launch dates or funding gaps, but to ask a much larger question. Where are we really going? The 2025 International Space Development Conference, hosted by National Space Society, will convene a global mix of visionaries, astronauts, engineers, private executives, and policy leaders to explore what the next 50 years of space development could look like. While many space conferences focus on the near term, such as payloads, rockets, deadlines, ISDC 2025 leans further into speculation and strategy. What is this year's theme, you may ask? A settlement on Mars and everything that comes next. I know it's not catchy, but it is deliberate at least, because the question is no longer can we reach Mars? It's what do we do when we get there and how do we continue to stay there? Speakers will include figures from NASA, SpaceX, Blue Origin, international agencies, and startup companies working on everything from orbital manufacturing to space-based solar power. But the tone is less corporate and more collaborative, tapping into the roots of long-term planning and what some are calling civilization engineering. Now, there are some topics this year that include the following: how to build self-sustaining off-Earth habitats, terraforming ethics and timelines, new propulsion systems for deep space travel, and the legal and moral framework for human settlement beyond Earth. Now, for those that maybe find that a little too abstract, there are some practical briefings, commercial station designs, asteroid mining tech, and even next-gen life support systems. For longtime watchers of the space industry, ISDC feels, I'm going to call it what it is, a bit like the Woodstock of future thinking, a place where ideas just aren't floated, they're probably smoked on a little bit, then schematically outlined, and may the best person win. There is actual enthusiasm, but it is anchored in engineering. And it really does arrive at the perfect moment. NASA's Artemis program, unfortunately, is still evolving and facing delays. China has an almost fully operational space station, and it is expanding. Europe, India, and Japan all have new lunar or Mars-adjacent goals. Meanwhile, commercial entities like SpaceX and VAST are pushing timelines that once belonged more in the books of science fiction. Now, this convergence of ambition and hardware is what ISDC is built for. To move the conversation from when we go to how we build once we arrive. Because getting to Mars may actually be what many call the hard part. But building something where staying there, that will be harder, and that's where it really needs to begin with. So that just leads us to this next issue. While ISDC explores where we go and how we live, some scientists are now asking perhaps a bigger question, and that is, can we even remake a planet? Now, we've all played the games, we've all seen the Star Trek movies, terraforming planets, or even in this particular case, terraforming Mars. The bold, controversial idea of transforming the red planet into a habitable world has long lived in the realms of science fiction, but this week, scientists and engineers are once again calling for the concept to be taken seriously. A new push covered by Space.com highlights how momentum is quietly building to reframe terraforming not just as fantasy, but as an actual long-term research priority. With crewed missions to Mars on the horizon and permanent settlements entering policy discussions, the question of planetary engineering is no longer entirely academic. At the core of the discussion is a deceptively simple goal: raise Mars's atmospheric pressure and temperature enough to allow for liquid water and eventual plant life. Doing so would mean generating greenhouse gases on purpose on a massive scale. And there are a handful of ideas that are already in play, such as deploying orbital mirrors to reflect sunlight and warm the surface, releasing CO2 stored in the Martian soils through targeted detonations or industrial heating, seeding the surface with synthetic greenhouse compounds, and even introducing extremophile organisms that might start a slow biological transformation. Now, all of this raises serious logistical and ethical questions. Terraforming would require not just global-scale engineering, but centuries of commitment. And any attempt to alter Mars would permanently change a pristine alien environment, one that may hold its own scientific secrets or microbial life. Still, proponents right now argue that now is the time to build the roadmap, not to launch a project tomorrow, but to figure out what steps would actually be required and what technologies need to be developed now to make any of it possible later. Interestingly, this new wave of terraforming talk isn't being led by some eccentric billionaire or some sci-fi writers. It's actually emerging from researchers in planetary science, atmospheric chemistry, and long-term habitat planning. They see it as part of the continuum of space exploration and not just a side quest. That said, there is no unified blueprint yet, no Terraform Mars Act waiting in Congress, but what's shifting is the tone. Mars is no longer just a place we might visit. It's increasingly a place we might settle. And if we're going to stay, we might one day need to make it feel just a little bit like home. That said, not every headline is built on fire and drama. Some come quietly on the wings of proven hardware, familiar trajectories, and rockets that now feel more like regulars than pioneers that they once were. That said, let's just take a moment and appreciate just how it doesn't make it any less impressive. On the 12th of June, SpaceX launched Starlink Group 15-6 from Vandenberg Space Force Base on the wrong coast, deploying 20 more satellites as part of its ever-growing broadband constellation. At the center of the mission was Falcon 9 booster B1081. Now, this is kind of a milestone that used to warrant celebration. Now, though, it's just part of schedule, and that shift from rarity of seeing a rocket re-land to now being commonplace. B1081 first flew in 2023 and has since become a workhorse. This latest mission saw it lift off smoothly, separate from the second stage, and return with textbook precision to the drone ship, Of Course I Still Love You, in the Pacific Ocean. And of course, the payload included 13 direct-to-cell Starlink V2 mini satellites, which will eventually allow users to connect to the network using standard smartphones. No bulky dish, no complex hardware. The remaining satellites on board rounded out the group, bringing added bandwidth and redundancy to the system. Now, it's crazy to think, as long as I've been doing this show, even I have failed to cover Starlink launches as much as I do, because, well, now they're coming about every 3 to 4 days. But I thought with tonight's story, it would be interesting to reiterate that as of this launch, there are still 6,000 or more Starlink satellites that are still in orbit. 6,000. That's a number no one would have predicted just 5 years ago, and it's increasing at an amazing rate. But beyond the growing constellation, missions like this one tell another story. That reuse works. That rockets can be refueled, reflown, and reliably return. And that the idea of launching a booster only once feels like a waste of money and highly archaic. And with every successful recovery, SpaceX chips away at launch cost, response times, and manufacturing demand. It's not just about lifting payloads, it's about rewriting the economics of getting to space. And when you're planning a budget like NASA and President Trump has been working together with, sometimes you have to find cost-saving ways that make sense. And if B-1081 is any indication, the age of single-use rockets is not ending anytime soon. Or it is ending, and it's way in the rear view. Now, while SpaceX refines this whole wonderful, amazing, can you believe it, launch routine, another launch is raising eyebrows, not for what it carries. Nope, no, not at all. It's about who it carries it with.
And now, assholes in space!
China's asshole! China is asshole! China is asshole! China is asshole!
Yeah, I'll never, ever get tired. On June 12th, China launched a new satellite from its Tianwan Satellite Launch Center, a seismo-electromagnetic research satellite that, on the surface, sounds fairly niche. Its mission, to boldly go where no satellite has gone. No, to truly study how electromagnetic changes in the ionosphere may relate to earthquakes. Okay, interesting science, possibly important data. But what turned heads wasn't the satellite sensors, but rather it was a roster of the collaborators. Alongside Chinese scientists, the project includes research teams from Italy and Switzerland, part of a broader initiative that's flown a little bit under the radar. Europe and China working together on Earth observations, climate science, and now electromagnetic monitoring of seismic events. The satellite, officially known as CSES-2, or Chinese Seismo-Electromagnetic Satellite 2, because China sucks at naming these things, is a successor to an earlier Chinese-Italian collaboration launched in 2018. That mission produced a trove of data, but also sparked subtle tensions about international cooperation in space, especially as China's long-term plans drift further and further from Western alignment. This second iteration carries improved instruments with an updated design focused on detecting pre-seismic ionospheric anomalies. In plain terms, it's trying to figure out if space can help us predict earthquakes before they happen. On the science side, it's actually kind of a fascinating experiment, because earthquake prediction remains one of the holy grails of geoscience, and any potential correlations between ground activity and upper atmospheric disturbances are worth investigating. But geopolitically, the timing is curious. Europe is still a close partner to NASA, and the European Space Agency, and they continue to tread a bit of a fine line, balancing its interest in collaborative research with growing pressure from the U.S. to limit high-tech engagement with Beijing. The launch also comes on the heels of increased Chinese investments in its space station, lunar ambitions, and more importantly, military-adjacent satellite platforms. None of this means CSES-2 is a spy satellite. Bullshit. I mean, it could actually be just legit, but it does highlight a growing split in global space partnerships and how science is often the foot into the door. For now, the mission remains above board, joint analysis, open data, and published results. But as low Earth orbit becomes increasingly crowded with commercial, military, and scientific hardware, the lines between collaboration and competition are only getting thinner. And if space is the final frontier, then sometimes It's also just a very awkward conference room in orbit. Now, while we have international partnerships expanding and satellites searching now for earthquakes, something else may be heading for a collision course. Everyone, get your small banners out, because it's happening right in our celestial backyard. Now, I know. We've heard it all before. Asteroids, near misses, extinction level events that turned to be nothing more than a fart in the wind. But this time, good news, the headlines don't warn of any earthly doom. They've picked a new target, the moon. NASA recently updated the impact probability of asteroid 2023 DZ2, and for the first time, the moon has been flagged as a potential target in 2032. Now, before you all think, okay, hey, this might finally do it, this isn't the kind of asteroid that would split the moon in half or shower us in space rocks. It's only about 210 feet wide, roughly the size of a decent building, and moving at tens of thousands of miles per hour. If it were to impact the moon, it would carve out a pretty nice new crater and give scientists a front row seat to the natural experiment we rarely get to observe in real time. Now, once again, before you all get excited, the revised odds are now just 1 in 5,500. I know, not apocalyptic, but there's hope. It's enough to warrant attention, right? Especially since NASA only added the moon to the list of potential impact sites after running more refined orbital models, because we know they get them right all the time. Now, it should be noted DZ2 made headlines last year when it buzzed Earth at a relatively close distance, about half the distance to the moon. Since then, astronomers have been keeping tabs, refining its trajectory, and accounting for gravitational influences from things such as the Earth, the moon, and even solar radiation pressure. The key variable is the asteroid's next close pass in 2026. If DZ2 gets just the right gravitational nudge, it could set itself on a course to impact the moon February 2032. And while theoretically it's going to be mostly harmless for us here on Earth, it could have some interesting consequences for ongoing future lunar missions. Because 2032, by then, NASA hopes to have a crewed Artemis landing on the moon's surface, and other agencies may have robotic or even semi-permanent infrastructures already in place. If DZ2 were to hit it near any of those regions, the resulting shockwave and ejecta could damage equipment or force trajectory changes for orbiting spacecraft. And that's why the scientists have a little bit of an erection on this. It's not just about waiting and watching the rocks hit things, which admittedly is kind of cool. It's about understanding momentum transfer, surface mechanics, and the ripple effects of high velocity impact on a body we're trying to settle. Kind of like me with Santa Maria every weekend when I dream. For now, it's just a probability. But in the orbital game, even long shots can become bullseyes over time. And in 2032, Luna might just find herself in the crosshairs. Now, before we continue with tonight's journey across the stars, it's time to drift a little bit, just for a moment, into the quiet between the pulses. Let's take a brief break, listen to 0 Point, let it play, let it echo, and we'll be back shortly after this. And we're back. Sorry about the slightly extended music break. Hopefully you enjoyed it. Having a fractured ankle, I wasn't sure I was going to get back in time to normal 3-minute break, so I put a 5-minute one there for you, so sorry about that. From the silence of zero point to the swirling magnetic chaos of a planet that's always tilted, always cold, and let's face it, always good for a punchline. If you ever wondered what's going on in Uranus, so has everyone else, including the Hubble Space Telescope, which recently caught a glimpse of something unusual, something twisting, hiding, and maybe even flickering beneath the planet's big icy moons. I don't know how I'm going to make it through this story. The culprit, a possible magnetic reconnection event, and it may be one of the clearest signs yet that Uranus isn't just tilted, cold, and forgotten. It's weird in ways we're only now just starting to decode. All the guys out here understand how hard it is to decode how to get there, right? So let's break this down a little bit for you. First, Uranus is tipping over about 98 degrees. It's basically is rolling around the sun on its side like a sleepy marble. That alone makes its magnetosphere behave differently than every other planet in the solar system. Add in the fact that its magnetic field is off-center, and you've got a celestial pinball machine. Now, thanks to recent Hubble data, researchers at Johns Hopkins have spotted signs of auroral brightening. Essentially, Uranian northern lights. Things are likely tied to magnetic reconnection events where twisted field lines snap and realign, unleashing bursts of energy. What makes this so fascinating, besides the jokes I could be making, is where it's happening. Near the planet's largest moons. Now, for those that do not know, Uranus has 5 major moons: Miranda, Ariel, Umbriel, Titania, and Oberon. And these aren't just icy rocks. Some may have subsurface oceans, and their interactions with the Uranus' chaotic magnetic field could be generating signals that rip across the planet's atmosphere. Think of it as Taco Bell night, a little bit of magnetic turbulence, a kind of cosmic indigestion coming from inside the Uranian system. And yet scientists are taking it all seriously. Because understanding Uranus's magnetic behavior could shed light on planetary dynamos, ocean worldwide detection, and even exoplanet classification. But it's also just a reminder we barely scratched the surface of this bizarre ice giant. Now, NASA currently has no flagship missions en route, but that hopefully may change. There's a growing pressure to send a dedicated orbiter in the 2030s, especially with Jupiter, Saturn, and Neptune already studied in depth. Until then, we only can subscribe to Uranus's OnlyFans. We can get a couple snapshots, couple hints, a flicker of a aurora, a magnetic pulse, and of course, the eternal jokes. Because no matter how advanced we get as a species, mine or yours, when you say something weird is happening on Uranus, there's always someone who will come up with a joke along the lines of, well, have you tried seeing a doctor? And you know what? I think I did pretty well getting through that story without too many innuendo and jokes. Oh, they were ripping through my head. Anyway, so from one misunderstood ice giant to a far more mistreated one, Pluto. Once again, reminding us that it's more than a rock, a number, or a committee's opinion. It is indeed, in fact, a planet. With the James Webb Space Telescope, having been peering into the deep, dark corners of the solar system. How you doing? And it's finding rather some surprising things at the edge of our planetary family. Pluto, the celestial outcast, the perennial underdog, is hiding a secret beneath its thin, nitrogen-rich atmosphere. A radiative haze so effective it's chilling the dwarf planet even more than previously understood. So let's unpack that, shall we? JWST detected a thickening layer of hydrocarbon haze, tiny particles forming high in Pluto's atmosphere. As sunlight hits, it causes complex chemical reactions forming tholins, reddish organic compounds that drift downward like alien smog. And let me all the stories I could tell you about that, honey. But here's the twist. This haze doesn't trap heat, it reflects it. And not just a little, but enough to drop Pluto's atmospheric temperature below what simple models have predicted. In fact, the haze appears to act like a radioactive heat sink, causing a thermal shadow that extends from the upper atmosphere all the way down to the surface. The effect, Pluto is colder than it should be, even accounting for its distance from the sun. I don't know. But rename it a planet again. Maybe it won't give you the cold shoulder. I'm just saying. Anyway, this makes Pluto the only known object in the solar system whose atmosphere cools its surface more than it warms it. A feat of thermodynamic weirdness that only makes it love us more. That said, this isn't just trivia. It has implications for exoplanets, comet behavior even, and the broader study of ice bodies in shadowed or eccentric orbits. If Pluto can develop this kind of haze, other cold world atmospheres might be far more complex than we previously assumed. Of course, it also adds yet another layer to is Pluto a planet debate? There's not a debate. Pluto is a planet. Because let's be honest, haze, weather, surface chemistry, moons, geological activity, seasonal cycles. Pluto checks a lot of planetary boxes. The only thing it lacks right now is political consensus. Thank you, Neil Dumbass Tyson. Because as James Webb reminds us, you don't have to be on the official guest list to throw a good party in the Kuiper Belt. Sure is nice if they would put your invitation back in the book, though. Now, that said, we have another distant world that's fighting for balance, dipping in and out of the habitable zone, like a cosmic fugitive on the edge of life and silence. In the constellation Cancer, 137 light-years from Earth, astronomers have spotted something both familiar and strange. A super-Earth, larger than our world, but smaller than Neptune, slipping in and out of its star's habitable zone. Its name is HD 85512b, and it was previously thought to be a misidentified signal, or perhaps just noise. But thanks to new data modeling and refined analysis techniques, it's back in the catalog, and it's got one of the most intriguing orbital quirks that anyone has seen yet. Unlike most exoplanets that hug their stars with clockwork precision, this one follows an eccentric, elongated orbit. That means for part of the year, it's within the so-called Goldilocks zone, the region where the temperature could, in theory, allow for liquid water. But only briefly. For much of its orbit, it is either too close and scorched, or too far and frozen. I know, guys, I know. We need to rename this one to Ex-Wife. It's a cosmic drifter crossing through that thin ribbon of possibility, then vanishing back into inhospitable, damn it, got me on that one, inhospitable extremes. It's been a while, okay? It's been a while since an ABLE word has tripped me up that badly. Let me regain my composure here. It raises a fascinating question. Could life evolve on a world that's only sometimes habitable? And scientists don't have a definitive answer, but theories are emerging. One suggests that if a planet has a dense enough atmosphere, or maybe a massive ocean, it could buffer the temperature swings, maintaining a semi-stable biosphere even as the light fades and then returns. Another theory posits that life may emerge only during the brief window of habitability, adapting to extreme cycles in ways we cannot yet imagine, like maybe a microbial hibernation or chemical pathways that flicker on with solar input, then vanish into a metabolic stasis. Either way, it is now more than a dot on a spreadsheet. It's a candidate, a question mark among the stars, challenging what we mean by we can live there. And the telescopes improve along the way and star catalogs grow. More of these Twilight Zone worlds are being found. Not fully in, not fully out, just passing through. And maybe, just maybe, that might be where some of the more interesting stories may reside. Now, if you felt nothing could top a planetary ghost or a moody super Earth, brace yourselves. Because somewhere out there, the universe sneezed. And it was loud. Astronomers have now confirmed what might be the most powerful cosmic explosion since the Big Bang, a blast so immense, so luminous, and so enduring that even Marvin the Paranoid Android might admit it was mildly interesting, is officially labeled AT2021LWX. This explosion wasn't a supernova. It wasn't a gamma ray burst. It wasn't a Vogon constructor fleet flattening hyperspace lanes either. It was something stranger. This event released more energy in 3 years than our sun will emit in its entire 10 billion year lifetime. Located about 8 billion light years away, AT2021LWX was first detected in 2020 by survey telescopes scanning the sky for transient events. Those brief comic flashes that can be supernova, black hole flares, or, well, whatever the hell this was. For a while, scientists weren't sure what to make of it. It didn't behave like any known explosion. It lingered. It paused. It carried on like a dramatic actor refusing to leave the stage. But recent analysis points to a more likely culprit, a supermassive black hole consuming a gas giant cloud, possibly even an entire star cluster. As the matter fell inward, it ignited a jet of energy that outshined everything else in the known universe at the time. Now, we are talking something 100 times brighter than a typical supernova, with an energy profile so intense it defies simple classification. And yet, it wasn't visible to the naked eye, not even close. The light was stretched by billions of years of cosmic expansion, reaching us in the form of X-rays, radio waves, and infrared signatures. You could be staring at the same patch of sky from Earth and never know that eons ago the universe threw a tantrum of mythic proportions. It's events like these that remind us the universe is not quiet. Oh, hell no, it ain't. It's just very, very far away. And now, while the guide advises you to always carry a towel, it might also suggest maybe keeping a pair of lead-lined sunglasses and a backup existential crisis in your side pocket, just in case your planet gets caught in the light cone of one of these things. To move over eccentrica galimbits, you may have been moved down to the second best bang since the big one. Now, space, we've been told, is a vacuum. Empty, cold, silent, much like my ex's heart. But in the strange math of quantum mechanics, that emptiness isn't nothing, and I know it's kind of a double negative. It's everything. And according to physicists, it may hold more energy than every star in the cosmos combined. Welcome to the wild world of vacuum energy, a theoretical infinite reservoir of power that exists in the fabric of space-time itself. This week, Space.com revisited the question that's haunted physicists and sci-fi authors for decades. Could we ever tap into it, giggity? The short answer, not yet. The long answer, maybe. but we would have to, rewrite the rules of physics and possibly voiding several warranties on the standard model. But here's the concept. Even in a perfect vacuum, no particles, no radiation, quantum fields still fluctuate. These fluctuations pop particles into and out of existence for fractions of a second, creating what's called zero-point energy. It's the lowest possible energy state, but it never actually reaches zero. Now multiply that across the universe. Calculations suggest that the total vacuum energy of even a single cubic centimeter of space could be astronomically high. In theory. In practice, it appears stable, balanced, locked in. The Casimir effect, one real-world demonstration of vacuum energy, shows that two uncharged metal plates placed extremely close together can be gently pushed together by these quantum fluctuations. It's not much, but it is something. The tantalizing idea is that if we could harness even a sliver of this invisible engine, we might be able to power ships, cities, or civilizations without ever burning fuel again. No sun would be required, just the hum of the void. But so far, the energy remains inaccessible. Any attempt to extract it might disrupt the very geometry of space-time. Some physicists even warn that fiddling with vacuum energy could destabilize the universe's underlying structure, likely pulling a thread on a sweater made of black holes. Still, the dream persists, not because it's practical today, but because even great leaps in science started as a question that made people very uncomfortable. Because deep down, we suspect the universe is hiding something enormous. In that quietest place imaginable. But we're not done. Not done yet. If you thought we were done bending the laws of physics, think again, because black holes might just be the universe's own large hadron collider. Hashtag CERN is innocent, but they're not really asking permission. For over a decade, scientists have used particle accelerators like the one in CERN at LHC to smash protons together at near-light speeds, all in the hope of catching glimpses of exotic matter or, with any luck, unlocking the mystery of dark matter itself. But what if we didn't need to build one? What if nature already made them? And made them terrifyingly bigger. Well, new research suggests that black holes, particularly ones interacting with companion stars or accretion disks, could function as natural particle colliders, firing subatomic particles into each other with more energy than anything we could ever dream of producing here on Earth. Here's how it works. When matter falls toward the black hole, it accelerates, spiraling inward in a high-energy dance. Along the way, intense gravitational and electromagnetic forces can push these particles to incredible speeds. These particles then can collide in the high radiation, high curvature regions near the event horizon, generating conditions ripe for rare, hard-to-detect particles to appear. And among these particles, possibly dark matter candidates. Because many dark matter theories, like supersymmetry or extra-dimensional models, suggest that the particles we're looking for don't show up under normal conditions. But just crank that energy high enough to 11, distort the space-time just right, and you might just get lucky. Of course, observing this from Earth is not going to be easy, but scientists are working on models to detect unique radiation signatures from these high-energy events. Bursts of gamma rays or neutrinos that hint at exotic physics in play. For now, it's speculative, it is early, but let's face it, it is kind of tantalizing. Because if it does hold up, black holes wouldn't just be the cosmic vacuum cleaners, they'd become laboratories, running experiments across the galaxy 24/7 with energies our best machines can't even touch. And if dark matter is out there, hiding in the seams of reality, this may be where it finally shows its face. Just somewhere at the edge of an event horizon, Two particles making sweet, sweet love, and the universe blinks. So while we have black holes playing mad scientists with the building blocks of reality, let's shift our gaze a little closer home, up and out to the skies above, where the light still whispers quietly, and the next 2 weeks bring their own cosmic stories. So here we are, the second half of June incoming, a stretch of darker skies, early risers, and celestial setups for what comes next. Let's start with the moon, or rather, the lack of it. On June 19th, we reached the last quarter, a perfect time for early morning sky watching, with half the moon illuminated and hanging high in the dawn. By June 26th, we slide into the new moon, giving us the darkest skies of the month. Prime real estate for stargazing, meteor spotting, or just letting the Milky Way whisper overhead. Don't worry. The next full moon will arrive July 11th, just in time for the next airing of Lost Wonder podcast, where we will encounter the strawberry moon, which of course has many names across North America that my executive producer insists on me trying to pronounce every time there is a full moon, but I get a reprieve. That'll be next episode. But just let me warn you, each one is a mouthful, and each one carries a season in its syllables, so stay tuned for that. Let's move on to the planets. Jupiter owns the pre-dawn sky, rising just above 4:30 a.m. in the east. Look for it, 4 bright moons lined up like a landing strip. Saturn follows suit around 12:30 a.m., climbing slowly through Aquarius with that soft yellow glow that never twinkles. Mercury might make a brief showing around the 25th of June, low in the west, just after sunset, but you will need a sharp eye, clear horizon, and maybe just a little bit of luck. Venus, she's missing in action, tucked behind the sun for now, prepping for a late summer return. Overhead, the summer triangle is rising early each night, Vega, Altair, and Deneb following a giant celestial compass pointing toward July. That said, we have no major meteor showers this cycle, but with the new moon on the 26th, you've got one of the best windows of the season. So pack a chair, bring a snack, lose your phone for an hour or two, and seriously, the stretch between solstice and full moon, the sky gets quiet, but it never is still. So that's it for tonight's show. Thank you for tuning in, how and whenever you do. Special thanks to NASA, SpaceX, Space.com, Mars Technica, NASA Spaceflight, Popular Mechanics, and more for the stories and inspiration tonight. And hopefully by the next show, I'll figure out what failed on the SHR Media side to air this show. I apologize for everyone over there. It's still there, but it's not in the right place. So come back with me at the helm, the EP setting course, and the ship's computer sitting in the back, whispering star maps through static. This is the Lost Wanderer podcast. Until next orbit, I hope you enjoyed the show, learned a little bit, maybe, just maybe, had a laugh or two along the way.
The universe is a pretty big place. It's bigger than anything anyone has ever dreamed of before. So if it's just us, it seems like an awful waste of space. Right?
When I was young, it seemed that life was so wonderful, a miracle. Oh, it was beautiful, magical. And all the birds in the trees, well, they'd be singing so happily, oh, joyfully.